All right, CNT120, Chapter 1, OSI model. We're down to Layer 3. So Layer 3, Network Layer. Network Layer is responsible for actually moving the messages basically from one network to another one. Layer 3 is concerned with actually getting it from network to network or to the correct network. So IP or IP addressing is going to come into play here. IP Internet Protocol or IP addressing, Internet Protocol addressing is going to come into play here. So the IP addressing is there to get it to, as we said earlier, the York network as opposed to the Lancaster network of Hack. Or this branch of my company as opposed to the Pittsburgh branch of my company. So Layer 3 is really about this getting it to the correct network. So here, the main piece of equipment that's going to do that is my router. Router or routers are going to read this information, get it routed to the correct network. Once it's in the correct network, another device is going to take care of getting it to the right node, the right computer, namely our switch. So the network layer is responsible for this. It's kind of like the postal system, the postal mail sorter, trying to get it to the correct town or the correct street. And once it's there, it's like, okay, somebody else is going to take care of getting it to the right house or the right person. So this is kind of like your post office, getting it sorted, going the right direction. And once it gets going the right direction, somebody else is going to take care of getting it to the right post office box or the right house kind of thing. So this is the job of my router. The router is going to read this addressing and consult its table and go, oh, I know where that network is, and pass it this way as opposed to this way. So down here I have a reminder of, here's my commercial grade router, here's my homeowner grade router. They are going to do that. They're going to read these IP addresses and using protocols like IP, the main one, a couple of these other protocols to help, to get these pieces of data, these chunks of data, to the correct network. That's what's happening at Layer 3. So to do that now, let's go back to our data encapsulation. We had this chunk of web page, move down through layer 765. Once it got to layer 4, TCP header got added for control purposes. So we now call this thing a segment. When it gets to layer 3, you'll notice that the TCP header is still there. What now happens is an IP header gets added on the front. So start thinking these almost as like Lego bricks now. When HTTP was here, that was one Lego brick. The TCP header got added. It was another brick stacked on top. Nothing got taken away. The TCP header got added on the front, almost clicked onto like another brick. Well, now when it gets to layer 3, an IP header gets clicked on top of that, almost another layer brick on top of that, Lego brick on top of that. So now the IP header gets added with the IP addressing information of where it needs to go, so the routers can read that and get it to the correct network. So this is now called a packet. This is where we truly have the term packet. When we have the piece of data with the TCP header and the IP header, this is now officially called a packet. And the routers are going to read and route these packets to the correct network. All right, layer 2, data link layer. Data link layer. Data link layer is responsible for getting my data off my computer and onto my network, if you will. So finally out of my computer through my network card and onto the network. That's the job of the data link layer. So the main piece of equipment that's going to do this is my network card. That's the main piece of equipment that's going to do this. My network card is going to get my data onto the network. It's responsible for media access. It's responsible for getting the data onto my wire, so I put little air quotes around there, onto my wire. If I'm using a wired Ethernet, it's going to be a wired Ethernet NIC. If I'm using wireless, it'll be my wireless Ethernet NIC. It's responsible for getting the data onto the network. And it's going to be using protocols like Ethernet, and I threw some of these older ones in here as just a kind of an example. It's either going to be using Ethernet signaling or wireless signaling, which is a derivation of Ethernet. So I'm going to be using this type of signaling here. 802.3, IEEE 802.3 for wired Ethernet, or IEEE 802.11 for wireless Ethernet. And that's what my NIC is going to be processing to get the data onto that network. So my main piece of equipment is my network card, and that is the piece that's going to get my data onto the network. And that network card has the MAC address on the media access control address that's burnt into the NIC to identify that computer on the network. That's burnt into that. Again, we're gonna work with MAC addresses in Chapter 3, so just kind of keep that in the back of your brain for now. The MAC address or media access control address is burnt into the NIC to identify that computer on the network. So at layer 2, and here's an example of a MAC address to give you an idea of what it looks like. Okay, it's a hexadecimal number. So my main piece of equipment here is my network card, connecting my device to my network, and it's usually going to be connected to a switch. That's why I have the switch here. So my network card is typically going to be connected to a switch. So these are the two main pieces of equipment that are working at this layer to move my data around. So at layer 2 now, okay, so we had the piece of web data moving down through. It adds the TCP header, so now it's called a segment. Layer 4 segment, TCP header added. At layer 3, the IP header was added. Again, it's added to on top of, so another Lego brick snapped onto the front. So it's added on front of that TCP header. So this thing now at layer 3 is called a packet. That's an IP packet. At layer 2, we add the Ethernet header because we're usually using an Ethernet network. Okay, so that's why it's an Ethernet header. It's going to contain that MAC address that we mentioned a little bit ago. It's going to contain that MAC address of like, hey, it's going to this computer. Can you get it to this computer? When we add this Ethernet header on the front with that MAC address in, this is now called a frame. This is now called a frame or an Ethernet frame. This whole thing right here is called an Ethernet frame. Okay. Layer 1 of my network is really concerned with getting this data from A to B. So now we're talking about this physical wire, if you will, or the RF radio frequency wireless transmission getting from my computer into the network, or from the network out to my computer if we're going the other way. So it can be transmitted through the air, could be transmitted across a copper wire, or it could be transmitted by light across a fiber optic cable. Could be transmitted any one of those ways. And devices like these are going to get it done. These are some media converters and things down here, along with repeaters, and these are hubs over here too. These are hubs, really old, okay? But these are the devices concerned with moving my signals around. Here's my different types of cabling. Here's twisted pair cabling. Here's some fiber optic cabling. Moving my data from A to B. Well, these are typically going to be either pulses of electricity or pulses of light. So they're typically going to be ones and zeros, bits that we're actually sending. Pulses of electricity, a pulse of electricity followed by nothing would be a 1 and a 0. Pulse of electricity 1, no electricity 0, 1 0 1 0. So I can be sending pulses of electricity to represent these bits, or I could be sending pulses of light to represent these bits across a fiber optic cable. Pulse of light is a 1, no light is a 0. Pulse of light is 1, no light is 0. So at layer 1, my cabling is going to move or carry my data from A to B in the form of bits. And those bits are going to be those pulse of electricity, pulse of electricity followed by none, 1 0 1 0, or pulse of light followed by no light, 1 0 1 0. So my data at this point, all of this is coming down through these layers. When it gets to this point, it literally is these 1s and 0 bits that are getting transmitted across the copper cable, the fiber cable, or through radio waves through the air. And these are now called bits. Okay, so as I move my data from my source over here, it's going to get encapsulated down through the layers, sent across the network to the receiver, and the receiving end is going to slowly depackage it, if you will, or de-encapsulate. So early on in the chapter, they used the example of sending a letter. Well, if I send a letter, I literally, write it out, I fold it up, I put it in the envelope, I seal it up, I put the address on, and I send it. It goes through all the postal system, etc., etc., and it goes to my friend's house or, my grandmother's house or whoever it happens to be. When they receive it, they get it out and they go, well, oh, this letter's from me. And they slowly open it and they start depackaging it. They start de-encapsulating it so they can pull the letter out and read a note that says, hey, happy birthday. I hope you have a great birthday. And they're going to de-encapsulate that to take it apart to read it. The same thing is happening with our data. I need to package it up in a certain way with all of those header fields. It's going to send across the network. When it gets to the other end, it's going to slowly tear those header fields off until it's readable and can be displayed in the browser or in my email or whatever it happens to be. So this data encapsulation process happens every time I'm sending something. That way the receiving end can slowly tear it back off, all these headers back off until it can get to the data and display it in my email or in my browser. This is happening every time I'm sending someone across a network. And here's a mnemonic to remind me about my protocol data unit names, the names of my data at my layers. The upper layers we typically call it data. 7, 6, and 5 we call it data. Layer 4 we call it a segment. Layer 3 we call it a packet. Layer 2 we call it a frame. Layer 1 we call it a bit. So I always use the mnemonic don't send fill for bill to get my data segment packet frame bit. Don't send fill for bill, data segment packet frame bit. That gets my data encapsulation units in order from 7 to 1. Don't send fill for bill, data segment packet frame bit. As I look at the example, this is similar to the one that's in your book. This shows data moving through a network. In my browser, I'm going to package up the data. And here shows the payload, the segment, the packet, the frame, and there's all the headers being added. Again, think of that as like Lego bricks just adding to the front. When it gets to the switch is going to unpack it just far enough to read this header address here, this MAC header, to go, where's this going? Oh, it's going to the router, and let me send it there. The router's going to unpack it far enough to find what network are you going to. Oh, you're going to this network. I know where that goes. Send it on. The web server is going to unpack it the whole way to go, oh, you want my web page? Okay, let me get that for you. And it's going to turn around and package it up and literally repeat the process going back this way now. Router to switch to workstation. Okay, so that's what's happening, and that's why all these headers are here so that this device can read the layer 2 information it needs, the switch. The router can read the layer 3 information it needs, and then the web server can read the layer 7 information it needs. And that's why I call them these like Lego bricks. It's going to peel it off far enough to read it, and then put it back to send it on. Peel it off far enough to read it, put it back on to send it on its way. That's your data encapsulation process. All right, last podcast, we'll talk about the little section on the end on safety and troubleshooting.